The following content is created by DrAvitech. Your support and donation will help me continue to offer high-quality educational resources for free. To make a donation, send an email to 6drcyril@gmail.com or comment donations below. Welcome, ladies and gentlemen, and in this video, we're going to be solving this very problem. My name is DrAvitech. Let us get started. Determine the Fourier series for the periodic function that. Okay, now the first thing I want to do is I want to graph that function. It's very easy to graph. Remember, I graph every function apart from when it has to do with parabola because it's then useless to me. But let's see. What I'm going to do here is let us draw this graph. It's actually very easy to draw. It's very easy. So this is y, which is my f of x. So this is my f of x. Now, I've got minus 2. So this is minus 2. And I've got positive 2. Now, this is 0 for x, this is minus pi, and then this is pi. Now, from minus pi to 0, from minus pi to 0, it was minus 2. So I kind of have something like this. It was minus 2 throughout. It was minus 2. So it was this line that you have here. Then from 0 to x, it was at 2. So from 0, this is 0 to pi. So from 0 to pi, it was a positive 2. Good. Even though this pi might be looking very far. Okay. So this is what I have. Now, ideally, this is how my graph should look like. Yeah, but let me make it much more fine. So I'm going to put a line here to take it to x, and then another line here to take it here. Good. So this is what I have. Now, do you know that this very function is an odd function? It's odd because I am having the same thing on opposite sides. So what it means is this is symmetric at the origin. At the origin. Because right now, I'm having something at this quadrant and I'm having something at the other quadrant. Normally, I actually say that this is like a 180-degree rotation. So you rotate this the first time it comes here, rotate it again, it comes. It's like you're picking this guy. So when you pick this guy, it comes here, this is 90. It comes here, this is 180-degree. So right now, this is an odd function. There's a video, I've explained odd functions. Take out some time to look at it. Now, if a function is odd, the only thing you need to find is b sub n. The only thing you need to find is b sub n. Not just that, but the b sub n would even be a reduced part. Look, b sub n is 1 over pi, integral from minus pi to pi of f of x sine nx dx. That's b sub n. By the way, if you've not yet hit the subscribe button, hit the subscribe button. Like this video, comment something, say something nice. So this is what we have. Now, do you know that since this function is odd and my interval was split, what I mean was it is symmetric. Not only was it symmetric, it was also split. So there are conditions for this. So my b sub n would then be 2 over pi integral from 0 to pi of f of x sine nx dx. This is what I'm going to be having. So this is like a simplified version of this formula. These two things are the same. This one is used because the function is odd. You were able to determine that the function is odd. So I already explained how this formula came about. I don't think I should be making the video long because I want to explain this again. So this is what we have. So this will be 2 over pi integral from 0 to pi. Now, what is f of x? F of x is 2. Because if you look at the interval of the integration, or limits of the integration, it's from 0 to pi. So f of x here was 2. So this will be 2 sine nx dx. Now, the next thing I want to do is, 2 is a constant. So let me bring out 2. 2 is a constant. So let's bring out 2. So since 2 is a constant and 2 comes outside, this will be 2 times 2, so that's 4. So this is 4 over pi, integral from 0 to pi. What will be left will be sine nx. So we're going to be integrating sine nx with respect to x. So that's what we have. Now the next thing I'm going to do is, this is equal 4 over pi. Now, if you integrate sine, you will get minus cosine. So this is minus cos nx divided by, differentiate the nx, you will get n. So this is over n. And then our limit is 0 to pi. Beautiful. That's beautiful, actually. Now, what is the constant here? Because everything is with respect to x. So what's the constant? The constant will be minus and this n. So let's bring out the minus. Let's bring out the n. So this will be minus 4 over n pi. So the minus is outside, the n is outside. And then cos nx from 0 to pi. All right. Now the next thing I'm going to do is, anywhere I see x here, I'm going to be putting pi. And then when I see x the second time, I'm going to be putting 0. So this will be minus 4 over n pi into cos n pi minus cos 0. Evaluating the limits, that's what I'm going to have. And this is minus 4 over n pi into cos n pi has a special value. Cos n pi is minus 1 to the power of n. It's a special value. Minus cos 0 is 1. Cos 0 is 1. Now the thing is, this is actually my b sub n. That's actually b sub n. But this bracket you see, it kind of have a behavior. It's a very funny guy. It has a behavior. Sometimes it is 0, sometimes it is a number that is not 0. So let's see. I kind of know what the number will be, but let's see. So when n is even, what's going to happen to this? We've got minus 1 to the power of n minus 1. So this minus 1, let's say n is 2, for example. Remember, we're only dealing with this bracket here, because this n here outside has a different behavior entirely. The one here has a very special one, because the answer for this bracket when it's even is the same for all even numbers. The answer for this bracket when it's odd is the same for all odd numbers. So the behavior of this bracket is important, not this very one. This very n has different behaviors. There's a different result for this when it's even and when it's odd. Now minus 1 squared is 1. So 1 minus 1 is what we have, and that's 0. So what this means is whenever n is even, no matter the even number you pick, this bracket will be 0. So this means that b sub n, which is minus 4 over n pi, times this bracket will now be 0. So this is now 0. So this means that whenever my n is even, my b sub n is 0. So you can see that life becomes easier. So I just know that whenever I'm evaluating my Fourier series, I don't need to put even values. It's just going to be 0. Now let's see. When n is odd, what's going to happen to this bracket? So minus 1 to the power of 3 minus 1 is equal, minus 1 cubed is minus 1. So I have minus 1, so that's minus 2. So this means that our b sub n, which was minus 4 over n pi times the bracket is now minus 2. So when you multiply, this will give you 8 over n pi. So this is what we have. 8 over n pi. That's what we have. So finally, we can get our Fourier series expansion. So f of x is equal the sum from n equal to 1 to infinity of b sub n sine nx. So that's what we have. Now, let us put in our b sub n. So this is the sum from n equal to 1 to infinity. B sub n is 8 over n pi sine nx. Now remember that this is when n is odd. This is when n is odd. Now, here's the thing. If the question says in terms of n, leave your answer. In terms of n, leave your answer. Though for students in the University of Benin, you're not asked this question. I think they've only done it once though. So in terms of n, leave your answer. We know that n is odd. There's no such expression as coming here to put n equal to odd in a function calculator. So you can't do this. Instead, there's a better way. Replace all your n with 2n minus 1. This value is always odd. Always odd. That value is always odd. So instead of putting odd under here, just write that f of x is equal to the sum from n equal to 1 to infinity of 8 over this n you see here becomes 2n minus 1 pi, and this is sine 2n minus 1x. Now this value, if you like put 1 here, if you like put 2 here, if you like put 3 here, all of these coefficients will be odd. And that's the beauty of it. That's the beauty of it. But let us write some expressions inside. Please take note that this is used if they say leave your answer in terms of what? In terms of n. So let us write some numbers inside our Fourier series. Now we know that f of x is equal to this. So let us get started. This 8 over pi is a constant. 8 over pi is a constant. So let's bring out the constant. So this is 8 over pi with the sum from n equal to 1 to infinity. What will now be left? If the 8 leaves here, there must be a 1 at the top. It's a fraction. So the fraction will not just disappear. That's 1 over n sine nx. And in fact, this 8 over pi can even come outside. Yeah, this thing would have even been much more simplified. The 8 over pi, since it's a constant, can actually come outside. I didn't really factorize it earlier, but that's just it. So this, hold on, let me just write the other expression. So it's still the same thing, I just did not factorize the constant out. So 8 over pi, the sum from n equal to 1 to infinity of 1 over 2n minus 1 sine 2n minus 1x. So it's still the same thing. It's still the same thing. Some difference. So this is 8 over pi. Now this summation, let's start. Anywhere we see n, we're going to put 1. So this will be sine x. Because when you put in 1 here, 1 over 1 is still 1. So that's just sine 1. Sine 1x is still x. So just put that. Plus 1 over 3. If you notice, I did not put 2. Because if you put 2, that means you are violating it. Because whenever it's even, it's 0. So you're not going to put 2. That's why this one is confusing. But this one, your answer would be correct all the time. Because no matter what you put n as, you'll be getting odd numbers. So sine 3x, and then plus 1 over 5, sine 5x, and then 1 over 7, sine 7x, and just like that. So this would then be the answer to the question. And with this, we're done with solving this very equation. Thank you very much for watching. I'll see you in the next video. Bye.